Hey y'all, today we are going to talk about the exterior angle theorem. Now, let's go ahead and take some notes on the sheet of paper that you have regarding exterior angles. So let's go over a few things that we should already know. Angles 1, 2, and 3, 1, 2, and 3 are inside the triangle. So that should be obvious. Therefore, we call those interior angles because they are inside the triangle. If we draw a line to extend one side of the triangle, it forms the exterior angle, which is angle 4. This line was drawn outside of the triangle, and that angle that meets right next to that interior, the outside one, is called an exterior. Exterior angles have friends that we call remote interior angles. They are the interior angles that are not adjacent to the exterior. Angles 1 and 2 are going to be your remote interiors. We call these remote interiors because they are not next to the exterior. They're not adjacent. They are away from the exterior number 4 angle. These are the furthest away from the exterior. So 3 is interior because it's inside, but it is not a remote interior. Remote interiors are away from the exterior outside. So the interior angles, we're going to label these. The interior angles 1, 2, and 3. 1, 2, and 3. The exterior angle 4. And the remote interiors are furthest away 1 and 2 because they are not adjacent to that angle 4. Now, let's look at a few examples. What are the interior angles of this particular example? Interior, so all of the inside angles. Interior angles, we're going to have A, B, and C. All 3 are interior. The exterior is the outside angle, which is D. And then the remote interiors, remember, it is not beside it. It's the 2 furthest away, A and B. Now, let's look at this example and see if we can continue. What are the interior angles? M, K, and P. What is the exterior angle? W. The remote interiors, remember, they're the furthest away, K and P. Notice these were on a different side of the triangle because you always look at the extended line. You look at that exterior angles line. Okay, let's move on down and let's see if we can understand what's happening here. Let's have a look at angle 3 and angle 4. So angle 3 and 4 right here. What do we know about these 2 angles? They are side by side. We call that adjacent. Adjacent means side by side. They are forming a straight line. Look at this. 3 and 4 form a straight line. What do we know about straight lines? Straight lines equal 180 degrees. We also know from using the triangle sum theorem that we learned that angles 1, 2, and 3 are interior angles. They have to add up to be 180 degrees. So now we have 2 different things that equal 180 degrees. The interior angles, 1, 2, and 3, and our interior and exterior side by side adjacent add up to be 180 degrees. Since both angle combinations equal 180, we could say that angle 3 and 4 right here equal the same thing as angle 3, 2, and 1 together. So if we take angle 3 out of the picture, angle 1 and 2 equal angle 4. What is angle 4 called? An exterior angle So this is the heart of the exterior angle theorem. The measure of the exterior angle is equal to the sum of the two remote interior angles. So if you're looking back at our original example, angle 1 plus angle 2 equals angle 4. You can add these and it equals this. Let's look at a few examples on the back. So, looking at our first example, angle 4 is our exterior angle, the outside angle. And the remote interiors, remember they're the two angles that are furthest away. So those two, 80 degrees and 50 degrees. Since we know that an exterior angle is equal to the sum of the remote interiors, how much is this exterior angle 4? How much is it worth? 80 plus 50, 130 degrees. So what does that obviously make angle 3 worth? Well, if this is a straight line, 180 minus 130, angle 3 on the inside has to be worth 50. And you can double check your work by saying 50 plus 80, your interior angles. If they add up to be 180, you have correctly answered the question. So let's try 2 at the bottom. Find the measures of angles 3 and 4. Okay, so we know that they form 180 degrees, but we don't know either one of the measures. So we need to go ahead and look at these two interior measures. 79 plus 49. 79 plus 49 has to equal the outside angle 4. What is 79 plus 49? 128. Good. So if this outside is 128, how are we going to find the inside? By subtracting from 180, because this is a straight line. What is 180 minus 128? 52 degrees. Let's try one more. Looking at this, we have a lot to answer. They want to know what x equals, what k, the angle is, what 9x, and what 5x plus 3 would be. So how would we go about solving this? You could use all of your inside angles to form 180, but when you have two different variables, you probably don't want to start that route. You could start off by saying that you know this is 180 degrees, a straight line. So what is 180 minus 115? 65. So K is equal to 65 degrees. So you can go ahead and fill that in right here, 65 degrees. Now, how are we going to find x, 9x, and 5x plus 3? Hopefully you remember what we did yesterday, and you set up an equation with all of your interior information equaling 180. So 65 plus 9x plus 5x plus 3 equals 180, because that's all of your interior information, and you know that it all equals 180. You could also set up 9x plus 5x plus 3 equals 115. Either way would work. So let's combine like terms here. 65 plus 3, so we have 68 plus 9x and 5x equals 180. Now do your inverse operation, 180 minus 68, and you'll get 112. So 14x equals 112. Divide by 14 on both sides, and you get x equals 8. Now, remember, that is only x. That is not the value of the angles. So x equals 8, Now, actually plug that in to find your angles. 9 times x of 8 will give you your 9x degree, 72 degrees. Plug this 8 in right here. 5 times x, which is 8, 5 times 8, then plus 3, 43 degrees. Now add all of your interior angles. 65 plus 72 plus 43. If it equals 180, you are correct. I hope this helps. Y'all have a great day. Bye.